Assume that x and y are both a differential function of t. Find dx over dt when x is 11 and dy over dt is -4. So you have to use this equation, right? This equation will give you kind of, the connection between x and y variable. Okay, this is given, and also, you know, dy over dt, the rate of change of y, which is -4. If this is the case, the question is, hey, could you find dx over dt? You need to figure out when x is 11. So this is the question, right? Okay. So what is our task? Our task is to find the derivative of x with respect to t. That means, let me recall this equation, say, which is 1. So what I'm going to do is I'm going to take the derivative, okay? So differentiate the equation number 1, okay, with respect to the variable t. Remember, x and y, both variables are functions of t. So if you look at the given x, the equation x and y has the product sign, therefore you have to use the product rule. So now simply I'm taking the derivative both sides with respect to t, right? Okay. Now here I'm going to use the product rule. Remember, recall the product rule. The derivative of u times v. If you want to find the derivative of the product, this is simply first function times the derivative of the second function plus second function times the derivative of first function. Okay, this is the simplest version of writing the derivative of product rule. Okay, now in this case my u is x and my v is y. Okay, so let's apply this product rule. So first function times the derivative of second function plus second function times the derivative of my first function, right? So this is the basically derivative answer you will get for the left side of this equation. Now if you look at the right side, that constant derivative is always going to be 0. Okay, remember we are asked to find dx over dt. We don't know this guy. We need to figure out when x is 11. Simply plugging these two values, dy over dt -4 and x is 11 here. But remember, we don't know y, right? But we could find y when x is 11. Simply use the original formula and find y when x is 11. Okay, so if you look at that formula, right? So the formula number 1 will give you, right, when x is 11, simply plug in 11 here and find y. Then 11 times y, which is 99, and solve for y. So y is simply 99 over 11, which is 9. So when x is 11, then y is 9, right? So simply plugging all the values here and find out dx over dt. So x is 11, dy over dt is -4, plus we don't know y is 9 when x is 11. We don't know dx over dt, so this is my question, right? So now this is simple equations. Solve for dx over dt. Find dx over dt. So that is -44 plus 9, which is dx over dt. So which is 0. So move -44 that side. I am solving for dx over dt. Okay. Therefore, dx over dt is simply 44 over 9. That makes sense?
Yes.
Okay. So like that, so all the problems has the similar type, right? So look at problem number 13. a point is moving along the graph of the function y, which is 1 over 6x squared plus 4, such that the derivative or rate of change of the variable x is 4 centimeter per second. Find the dy over dt when x is 3. The similar, sort of procedure, right? Okay. So let me do 13 somewhere here. Erasing this. And problem number 13. Given relationship between x and y is this. We know now dx over dt, which is 4. Again, like earlier, we need to find dy over dt when x is 3. That means you need to take the derivative, both sides with respect to t. Okay. Simply take the derivative both sides. Therefore, dy over dt is simply d over dt of 1 over 6x squared plus 4. So I'm rewriting this guy by using exponents. This is nothing but 6x squared plus 4 to the power negative 1, right? If you move the denominator to the numerator, move everything to the numerator. Okay, remember, again, I'm going to use the chain rule. Okay, I'm going to use the chain rule. So this is, I'm calling as u. So my u is here, 6x squared plus 4. That means u prime, which is, I need now with respect to t, right? So my u prime is here du over dt. Okay, so du over dt is simply now take the derivative with respect to t. Again, you have to use one more, chain rule inside. So this is t 6 times the derivative of x squared with respect to t plus the derivative of 4 with respect to t is constant, which is 0. So if you simplify further here, remember, again, you have to use here the chain rule. Let u as x, then you will get simply u squared, right? So the derivative of u squared is 2u, but remember using chain rule, so you have to, this u is different than that u, right? So we'll let it be, otherwise you will get confused. So I'm writing directly without using u. So the derivative of x squared is 2x, but remember you need to take the inside function derivative with respect to t, which is dx over dt. Okay, so that is basically my u prime. So if you simplify, this is 12x times dx over dt. Okay, so we need that, no? We need that. Okay, now go back here and find out. Now here, this is my u, therefore the problem is d over dt of u to the power negative 1, right? Chain rule says what? Chain rule says that you could take the derivative instead of tu, but inside function should be, differentiated with respect to t. So u prime is here du over dt, okay? Where u prime is du over dt. No confusion, right? We are taking the derivative with respect to t all the time. So now this is, use the power rule, negative 1 over u squared, right? That is this piece answer. U prime just now we got, which is 12x times dx over dt. But now u was actually 6x squared plus 4. So replace u by 6x squared plus 4. But I have square here, times 12x times dx over dt. So this is my dy over dt. Okay. Now what is the question actually? Question was finding dy over dt when x is 3. Okay. But we know dx over dt is 4 all the time. So I'm plugging these all values into the function and finding dy over dt. Okay. So finding dy over dt when x is 3. Okay. My dx over dt was 4. So simply plugging those values. So you will get here what? Negative 1 times 12 times. My x is now 3 over 6, 3 squared plus 4, whole thing squared, times dx over dt was 4. That's it. Simplify this and find the answer. So how much it is? 3 squared is 9. 9 times 6 is 54. 54 plus 4, 58. We have 58 squared, right? So use the calculator otherwise, and you should get negative. Could you check this, please? Check your calculator and type this. So dy over dt is negative 36 over 841, I believe. So a lot of things happening here, right? You have to use the chain rule, change of variable. Does that make sense?
Yes.
All last 4 problems, have sort of a similar procedure to do the problem. Only the functions are changed, right? So if you look at 14, again, you are given a function y is sine 2x, and dx over dt, which is 9. Question is again finding dy over dt when x is pi over 2, right? So do the same thing. I need to find now dy over dt, taking the derivative both sides with respect to t. Okay. So again, two times you have to use the chain rule. First, let this guy as u. Okay. So let u be sine 2x, right? That means u prime du over dt is what? Simply take the derivative of the sine. Okay. So that is the one I'm writing here. Okay. So du over dt is simply what? The derivative of sine, which is cosine 2x. But inside the function, you see now again you have to keep this as u. So when you take the derivative of that, it is going to be 2, right? The derivative of 2x with respect to x is 2. But remember, you are taking the derivative with respect to t. Therefore, you have to find the inside function derivative also here. Okay. So I'm using 2 times, the chain rule. One is here and one is here. So this is my u prime. So if you simplify, you will get 2 times cosine 2x times dx over dt. So that is my u prime. We need that. Now go back here and to find out the answer. Okay. So I have answer here, right? So which is 2 cosine 2x. Okay. Then times dx over dt. Make sense? That is my dy over dt. So question is again finding dy over dt when x is pi over 2, right? But dx over dt is 9. So plugging everything is here, you will get it 2 cosine 2 times x is now pi over 2 times dx over dt is 9. So that is 2 cosine 2 cancels. You will get cosine of pi times 9. Cosine pi is negative 1. So you'll get negative 18. Question? Are you following me?
Dr. Raj.
Yes, go ahead.
Just a quick question for the Cengage WebAssign program.
Okay.
does it automatically gauge how many attempts that you're allowed to do at a question, or is that set, or how does that work?
I'm not getting, your voice is not clear. Say
Oh,
it again.
sorry,
Yeah, loudly.
sorry.
No problem.
For the WebAssign Cengage homework that we do, is the amount of submissions that we're allowed to do per question, is that preset, or is that, how is that set up?
You mean the number of submissions you are asking?
Yes, sir.
It is, you could submit as much as you want.
For this, or I don't know if there's a way of me resetting it. I'm sorry taking up Zoom class time to ask this, but I was just curious. I don't know if there's a way for me to reset it or not, but whenever I check for details on the actual assignment homework, it only gives me 5 submissions for the five.
Oh, I see.
Yeah, and I'm now not able to do one of the problems because I was trying to figure out what I was doing wrong.
Is that
So
only for the particular sections, or throughout all the sections you are getting same number of submissions to me?
it changed. It only changed up for me this section, but the previous sections, I believe there was a submission cap of only 20 submissions.
Okay,
But
I will
now
take
it's
a
at
look
5.
at. I will take a look at. Could you tell me what is the section number?
2.4 chain rule.
2.4 chain rule. Okay, I will fix that today. Okay. So
Thank you very much, sir.
yeah. Thank you for letting me know.
Yes, sir.
Okay. So who else? Anything else? So we need to do the last one. So last one, we don't have any formula. You need to create formula, right? But it is a easy formula. So they're telling what the radius r of a circle is decreasing at a rate of 4 centimeters per minute. Find the rate of change of the area when the radius is 4. Okay, so they are talking about, the area of the circle, right?
Yes.
Okay, so let me write down the area of the circle formula. Remember here the radius r and area are variables, right? These two are going to be changed. When you change your radius, and automatically area is going to change, right? Now what's happening in this problem? In this problem, the radius r keep on decreasing, right? The rate of change of, the radius is given, which is 4 centimeter, but decreasing. Therefore, the rate of change of the radius with respect to time is now -4. This negative sign comes because, the rate is decreasing, right?
Yes.
Yeah, the radius is decreasing. So in this rate, so every minute the radius is decreased by 4 centimeter. So that is why we have negative sign. The reason is because decreasing. If it is increasing, you have to put +4. So now this is given. Now the question is what? You need to figure out what? Find the rate of change of area. That means you need to find out dA over dt. Rate of change means you are talking about with respect to time. They're asking us, hey, what is dA over dt when the radius is 4? You need to figure out this when radius r is 4. But we know the rate of change of the radius is -4. Like earlier, simply take the derivative with respect to t, in this equation. So if you take the derivative with respect to t, simply dA over dt is du over dt of 4 pi r, pi r squared. So you are finding the derivative of pi r squared. Pi is constant, so you could pull outside. Then d over dt of r squared. Okay, again use the chain rule. You could think of, r as u. So this is the derivative of r squared is 2r, but inside function should be differentiated with respect to t. That is my dA over dt. That's it. Now you need to find dA over dt when radius is 4. Simply plugging 4 here. We know dr over dt is negative 4. So this is going to be how much? Negative 32 pi. I'm keeping as an exact form, right? I don't put 3.144 pi because I don't want to round up, write in exact form. This is fine. So you see now you get negative sign for the rate of change of area. It makes sense, right? When you decrease the radius of the circle, automatically area of the circle also going to be decreased. So that is why you have here as well negative sign. That makes sense?
Yes.
Yeah. So these all kind of word problems by using the derivative. So I may put couple of problems similar to these 4 problems. It is all about applications of derivative. So let me know if there is any question so far in this problem setup. Okay. Now next one is here implicit differentiation. What does mean by implicit differentiation? Implicit differentiation means what? Suppose if you are given y, right? This guy maybe this side maybe with the function of again x and y. So that means if you try to find the derivative of y, you may have here, in your answer, you may have y as well. Okay, so your y prime dy over dx may have some other function, say h function, but this function may have x and y as well. So if you see, in your answer of the derivative inside, if you see the original function y, we call that as the implicit differentiation. Okay, in your explicit differentiation answer, that means in your explicit differentiation form, the y prime dy over dx always supposed to be only in terms of x. No more y here. So this is called explicit, differentiation of y. But this is implicit. Okay. That means what? That means you just simply solve for, y prime dy over dx. Take the derivative, right, with respect to, the x, then find dy over dx. That is called implicit differentiation. Let's look at a couple of problems from here. I'm going to work only 2 from here, okay? So let's do 3 and 4. Or I will do 2 and 4. Okay, the question is now finding dy over dx, y prime. You are given the equation x squared plus 2x plus 9xy minus y squared, which is 8. What is the question? Question is finding dy over dx. Do you see dy over dx here? In another word, do you see y prime here in this equation? Say yes or no.
Yeah. Yes, when you multiply it out.
Before that, I'm asking. If you look
No.
at this equation, do you see y
No.
prime here? No. There's no y prime. There's no dy over dx, right? That means what? That means you have to bring somehow y prime into this equation. Only way is simply take the derivative with respect to x everywhere. Okay? Simply I'm going to take the derivative of entire function, both sides. Okay? So if you do that, remember my left side, I have this much of terms. So I'm going to take the derivative one by one. So d over dx of x squared plus 2 times d over dx of x plus 9 times d over dx of x times y minus d over dx of y squared equals that side d over dx of simply the constant 8, right? Okay, now keep on, find the derivative one by one. So what's the derivative of x squared with respect to x, which is 2x?
2x.
Yes. The derivative of x with respect to x, which is
Yes.
1. So, which is 2 times 1. Now, this is the catch. Here's the place we have to use the product rule, right? Because now you have two variables, x and y. Okay? So, I'm going to use here product rule. You could think of this is function f, this is function g. Use the product rule. F times g prime, f times g prime, okay, plus g times f prime. My f function is now simply x. Remember, I'm taking the derivative with respect to x. Here, use the chain rule. You could think of, let y be u. Okay, use the chain rule. So if you use the chain rule, this is y squared, so you have to use the power rule. The derivative of y squared with respect to y is simply 2y. But remember, inside function y should be differentiated with respect to x, so which is dy over dx. This is the place you have to be very careful because ultimately I'm finding the derivative with respect to x, right? My inside function was simply in terms of y. So take the derivative with respect to y, then times the derivative of y with respect to x. This is simply I'm using chain rule. Now that side, the derivative of constant is 0. Okay, that is 0. So far so good. So now simplify everything. 2 times x, 2x plus 2 plus 9. Inside, let me write dy over dx as y prime plus y. Ex over dx is again 1. 1 times y is simply y, right? Minus 2y, again dy over dx, let me call as y prime. What was the question actually? Question is finding dy over dx, y prime, right? Now this is simple equation, solve for y prime. So, you know how to solve for y prime. You have to combine all the like terms, right? First distribute 9 with these two, terms. So you will get 2x plus 2 plus 9 times x y prime plus 9 times y minus 2y times y prime, which is 0. Now I'm going to combine like terms, these two, right? You see now, here and here, you see the y prime, right? So if you factor y prime in between these two, terms, it will be y prime times 9x minus 2y, right?
Yes.
Then I'm moving rest of the terms to the right side of the equation. Simply I'm moving these three, right, to the right side. So that means it's going to be negative 2x, negative 2, and then negative 9y. Okay, remember I'm solving for y prime, so you need to divide both sides by 9x minus 2y. So then you will get y prime, dy over dx. So these two will be cancelled. Therefore, y prime is, if you want, you could take the negative sign outside. So you could write 2x plus 2 plus 9y. And if you want, you could put one more negative sign in the denominator as well. Then cancel these two minus. So my answer is 2x plus 2 plus 9y over 2y minus 9x. So let me check with my answer. I already worked out this problem. The answer I gave you, any solution? Yeah. So we found y prime. So if you look at this side, it is an implicit form.
I actually have some questions, but it's more so around two. Oh, I haven't gotten to this because I'm assuming this is 2.5.
Okay.
But 2.4 with um, I'm still trying to do some stuff This sounds really bad. I'm still trying to do some stuff and finish out with a 100% for 2.3, and I'm
Okay.
about halfway done with 2.4. But it's I'll look at the Cengage reading and I'll watch the videos and stuff.
Mm-hmm.
But they'll just throw out problems that won't even be slightly covered in the actual material. But do you get this is a little late in the semester to ask this, and I'm most likely going to start using this a lot more as a resource. But in your personal videos that you go over each section, do you go over really complex problems with chain rule?
Um, how about the video you have in web design?
The are you talking about? I don't know the guy's name, but it's the same guy every time, and there's multiple videos usually per section.
Yeah.
I'll watch those over and over again, and he explains basic chain rule like dealing with just a square root
Yes.
function.
Yes.
But then you'll have stuff on Cengage that will be like 6x squared over a square root of another function, and it won't even be talked about in the section.
So
And
you are talking about what is the 2 point what?
2.4.
Oh, 2.4. Okay, so what about my notes? Did you check my notes? The class note I posted?
The class note? No, sir. No, sir. No,
You
sir.
have to go through there because I have worked a couple of problems from exercise and I have included some other problems as well.
Oh, okay, okay.
That's what you need to look at the class notes. So I already posted the class notes, right? So
Yes, sir. Yes, sir.
yeah, so for example, you see now for 2.4, you see the class notes I posted there.
Yes, sir.
You see the problem here, so you will find out some more kind of difficulty levels I have included here, and you see these all problems. Why don't you go through these all, and after because these all I picked from some other my class notes and all I'm preparing, and I have included so many problems here. You see here, right?
Yes, sir. Yes, sir.
Yeah. So again, I'm going to include some more problems here, and that I already posted there, I believe. So please go and check the worked out class notes. I already posted for up to 2.4.
Okay, okay. Oh, yes, sir. Yes, sir. I see what you're talking about.
Yeah. So then let me know if there is any problem again if you have. Okay.
Yes, sir.
Yeah,
I'm
I
sorry for
understand
that.
because the web design, assignments will have a lot of levels, difficulty levels. So they combine
Oh,
everything, and you will find out from all the way easier to the hardest.
yes, sir. Yes, sir.
Yeah. So that's what I'm giving here so many practice test problems, and yeah. Anything else?
I just figured I'd ask the practice test, has it already been put up for test 2?
Yes.
And that I know that the test is next week, but well, I can just set the calendar for that. I'm sorry.
Yeah. Yeah. Right. So let's work on problem number 4. Again, we are finding y prime, but the given function is now trigonometric function. Question is finding again y prime. We don't know. So I'm going to, find the derivative both sides. So find the derivative both sides with respect to x. Okay. So d over dx of tangent 13x plus 6y. This is my left side. My right side is simple function. Now here you have to use the chain rule, right? So let's inside function as u. So the derivative of tangent u, which is secant squared u but inside function u should be differentiated with respect to x, right? Okay, so that is u prime. This side 6 dx over dx is 1. Remember, my u was here 13x plus 6y. If this is the case, what is u prime? Remember, u prime is nothing but du over dx of this function, right? Now, move the differentiation inside, so you will get 13 times dx over dx plus 6 times dy over dx, right? Now this is 13 plus 6 dy over dx is nothing but y prime. So this is my u prime, right? I'm using the chain rule here. This is my u. So d over dx of tangent u is secant squared u times u prime. This side is simply 6. Now go back and replace the original variable here. U is my 13x plus 6y. Okay. And my u prime, just now we got 13 plus 6 y prime, that was my u prime, this is 6. Now question is finding y prime, right? So simply distribute inside. Remember, these all one term, no? Secant inside the angle is this. So distribute this first time and distribute this. So I'm talking about this, okay? No confusion. So when you multiply 13 times secant squared, you will get 13 secant squared 13x plus 6y. Then again 6y prime times secant squared, you will get 6y prime times secant squared 13x plus 6y. That side I have simply 6. Now you need to solve for y prime, right? So keep this term to the left and move this all to the right. So you will get 6y prime times secant squared of 13x plus 6y. That is equal 6 minus, I am moving this all to the right, 13 secant squared of 13x plus 6y. I'm solving for y prime, so divide by 6 secant squared of 13x plus 6y both sides. Okay, so when you divide, these two will be cancelled, right? So you will get simply y prime, which is 6 minus 13 secant squared of 13x plus 6y. Okay, that is my y prime. Okay, remaining all problem using quotient rule, product rule, chain rule, those things, no? Now tell me which one you want me to discuss. Do you want me to try these quotient rule problems, or
How many questions will be on the test?
I may include maybe 12 problems, 10 to 12.
Okay. Will it start the same time,
No, this time I'm going to.
like midnight, like it did the test number 1?
Do you want me? I am thinking to post early morning, 7 o'clock. So do you want me to put midnight?
No, that's what it was last time, and now it started at midnight and ended noon the next day. That was a little difficult. 7, 8, in the morning starting would be good.
Yeah. So I will give you from morning 7 to all the way night 11:59.
Good. That'd be better. Thank you.
Yeah. No problem.
So around 10 to 12 problems over these 4 sections, correct?
Yes.
Okay.
Okay. So let me discuss this one, number 6. I think Douglas was asking last time, right, about similar sort of problems. Remember? finding the points where the gradient of the tangent line, right, which is horizontal.
Yes.
So we are looking for the horizontal tangent line. At which point you will find out the horizontal tangent line, right? That is the question. So you are asked to find the points, right? Points means your answer is supposed to be in point form. So you need to find the x and y, okay? You need to find such points where the slope of the tangent should be horizontal. Tangent line should be horizontal. So if the tangent line is horizontal, we all know that slope is supposed to be 0, right? So basically we are looking for
Yes.
the points. Yeah, basically we are looking for the points where the slope is getting 0. That's it. So we know how to find the slope. Slope of the given function is simply the derivative of the function, right? So find the derivative of each function to be a horizontal tangent line. That slope supposed to be 0. So set it to the 0 for the derivative function, then solve for x. Okay. So problem number 6. First, let us find y prime. So problem number 1. You are given a function x cubed plus 15x squared plus 9. Okay. I'm going to find slope of this function. Slope of y, right, at any point x is simply y prime, right? So I'm finding now y prime x. Simply find the derivative of the given function. Okay. So we know the derivative property says you could find the derivative, one by one for each function. So the derivative of x cubed is 3x squared using the power rule. Again, the derivative of x squared, this is 2. The derivative of x squared is 2x, but here you have 15, so it's going to be 15 times 2x. Then the derivative of constant is 0. Okay, so now if you simplify this, you will get 3x squared plus 30x. So this is my slope, right? For the horizontal tangent line, slope supposed to be 0, right? It means your y prime x supposed to be 0. So we already know y prime x, which is this guy. Set it to 0 and find possible x values. So this will give you 3x squared plus 30x. This is my y prime should be 0 for the horizontal tangent line. Now this is simply a quadratic equation, right? Solve for x. Remember here, you could pull 3 as a common factor, not only 3, x also there. So 3x is a common factor. So that is x plus 10 here, right? Factoring. Okay. Now divide by 3 both sides will give you x times x plus 10. Supposed to be 0. That means what are the possible x values? Could you solve this equation? What are the possible x answers? Could you solve this? X times x plus 10 supposed to be 0. Then what is the possible x values?
-5 and 2. Are you trying to get it to cancel out so 0 equals 0?
You see now, here you have multiply sign in between these two.
So it would have to be the same x.
Mm.
I'm confused slightly.
You
sorry.
see, this is very simply, you are multiplying two functions, answer is 0. Then what are the possible x values you may have here? You see now, here you have x, here you have x plus 10. You are multiplying both of them. Your answer is supposed to be 0. That means the possible value, this first guy may be 0. Then only when you multiply 0 with something, you will get 0.
Yes, sir.
Or the second guy, x plus 10 may be 0. We don't know. Either one may be 0, right? Then only when you find the product of those two numbers is going to be 0. If this is the case, your x is supposed to be -10, right? If x plus 10 is 0, means x would be -10, right? So go back and check your high school work, finding the solutions for quadratic equation, solving quadratic, okay, and factoring. So brush up your knowledge of these guys, okay? So then if you solve this quadratic, you will get two possible x values. Or if you do not find this easy, so you could use b squared minus 4ac formula to solve this equation. Okay, and figure out the possible solutions. So I got two possible x answers. Remember, they are asking us to find out the points, right? So you need to find out the points means what? You need to find out x and y coordinate as well. You know only so far x values. There are 2 points, 2 different x values, but we don't know y values, right? Therefore, the points are, you need to find now, there are 2 points. The 1 point x coordinate is 0. You need to find now y, okay? If you know x coordinate, how do you find y coordinate of the function? Simply, you know the function formula, right? This is the given function, right? You know x is 0. Simply plugging here 0, you will find out the corresponding y coordinate, right? Simply plugging 0 into that function. Okay, so if you do that, this is going to be 0 comma, simply plugging x0 into your original equation. The given equation was x cubed plus 15x squared plus 9. Okay, simply plugging 0 here, you will get what? Y0 is 0, 0 plus 9. So which is 9. So this is 1 point, right? To find the second point, take the second possible x value. The second possible x value is negative 10. Now find the corresponding y. Again, plugging negative 10 into your formula and find y. So again, use the formula given and plugging now negative 10 in place of x. So you get negative 10 cube. Oops. So what is y negative 10? Simply plugging here negative 10. So you will get, let me do somewhere here. Y negative 10 is simply negative 10 cube, plugging here negative 10, plus 15, negative 10 squared, plus 9. Now take your calculator and simplify this, what you'll get. Check my answer. Could you check the answer?
509.
Say it again?
Did you get 509?
509. Let's see, this is negative 1000, right? And here
Yes, sir.
1500. And you will get 509. Yeah, you are correct. So therefore, that is 509. So this is my second point. Okay. So this is the way to find the points. Set it to the 0, the slope, then find the possible x values, then plugging those x values into the original function and find the corresponding y values. Then write in, points form, x and y coordinate. So these are the points now for the given function, have a horizontal tangent line. Okay, so then I have worked on remaining 2, so you could go through those solutions and make sure that you understand the same procedure. Okay. Anything else?
So, okay, it's something that I've been meaning to ask about what we've been going over with differentiation, derivation, and all of this.
Mhm.
I heard a comment probably last week. I've been looking up calculus videos and looking at stuff for sections with helping with this.
Okay.
And I heard a comment, or I think that the guy on Cengage actually said it, that most of calculus is built off of the idea of derivation and differentiation and stuff like that.
Right.
So just a question out of curiosity, what we're doing right now is it considered base level stuff and it's only going to get a lot harder from here?
Yes, these are the basic level, but throughout the Cal 1, you will have the basic calculus things. Only in Cal 2, you will have,
Oh, okay. So all of Cal 1 is just getting the base level stuff.
exactly. So there are two major things actually we are going to discuss it throughout this course. One is the differentiation, the one we are just now studying, right?
Yes, sir.
The another one is integration. These two are major branches in calculus, right? So first we will learn these things, then we will go back after a couple of weeks. We will go back to the integration and look. But both of these two topics have same weightage, same same applications and same useful ideas we have. Okay, use the product rule to do this problem number 7. So I already have put the solutions. Why don't you go through and check? So remember product rule, you have to think of always F times G. For the chain rule, you have to keep all inside function as U, right? Keep all inside function as U, right? So then you should be able to write down the original function in terms of U, then find the derivative with respect to U, then times U prime. So go back and check the chain rule, okay? So it's all very much, the similar problem you will have for the test. So if you have a good practice on all the problems here, you should be good.
Yes. We didn't. I don't. The alternative form wasn't done a whole lot, so.
Okay, so please go back and check my class notes. Do you guys check my class notes?
If I struggle with something, I will. But if I get it at the time, I usually don't.
You need to go through make sure that you go through my class notes, because I used to put all kind of level problems there to discuss. Okay, so there are two formulas actually we had. One is finding the derivative in terms of any x value. This is the original, the first version of our derivative. Very first we had this formula, right? The second alternate version is alternative form is nothing but finding the derivative at the particular point, say A. This is simply limit x goes to A of fx minus f of A over x minus A. So they're asking us to use this form to find the derivative of f at the given point A. Okay, so if you look at the problem, you know the function now, fx is given. You know the point as well. Point is 1, 5. Therefore, the x value of the point is x coordinate is simply 1. Therefore, A is 1 in this problem. Okay.
Okay.
Right. So now fx is 5 over x cubed. So we are going to find the derivative at 1. Okay. So the question is finding derivative at 1. They are asking us to find out this. Simply use this limit version formula. So I'm simply applying this formula. A is now 1. So f prime at 1 is nothing but limit x goes to 1. My A is now 1. Fx subtract f of 1 over x minus 1. Right?
Right.
Right. Now what is fx? Fx is here. Simply plugging that. Then how do you find f of 1? Let's see who is telling. What is f of 1?
5.
5. Simply plugging 1 into your fx function to get 1, right? So f of x is 5 over x cubed. Therefore, f of 1 is simply plugging 1 here, which is 5 over 1 cube. That is 5. So you know all the values, simply plugging here. So this is going to be limit x goes to 1. Okay, fx was 5 over x cubed. Subtract f of 1 was 5 over x minus 1. Now you have more work. You need to find this limit. Limit problems, right? Chapter 1. Finding limits. Okay. So before going to do that, you have to simplify further. This is limit x goes to 1. So I'm going to combine these two. Remember here I have one common denominator is x cubed. So if you combine these two fractions, you will get basically the cross multiplication, right? 5 times 1 is 5. Subtract 5 times x cubed, 5x cubed. This all over the common denominator is x cubed. Okay, so this is the one you will get in the numerator. Over the denominator is simply x minus 1. Right? Now I am just moving x cubed to the the denominator. So you will get 5 minus 5x cubed over x cubed times x minus 1 in the denominator. Now do some algebra. I could factor out 5 in the numerator. So I could pull one negative sign here, and I could write that as 1 minus x. Right? Now remember we did similar problems in chapter 1. How do you find the limit? If you plug in 1 for x, you will get 0 over 0 form. Do you see that? So therefore you have to use some technique to get rid of that. So remember what kind of technique we used? You could use the factorization, or you could use the long division method to find out, right? Now go back and check your high school work. You know how to factorize a cube minus b cube. Do you remember? A cube minus b cube is, if you factor a cube minus b cube, a and b are any real numbers. This is simply a minus b times a squared plus ab plus b squared. If you factor a squared plus b, a squared minus b squared, this is called the difference of square, right? This factoring is a minus b times a plus b, we call. And the third important formula or factorization of a cube plus b cube is simply a plus b times a squared minus ab plus b squared. Okay, so now which one I have? I have now minus sign with the cube, the first formula. Use the first formula and factor this guy. If you look at the formula and the given problem, my a is here 1 and my b is here x. Okay, so if you're plugging 1 here and x here, you will get simply 1 minus x cubed. Right? That is simply 1 minus x, then 1 squared is 1 plus a times b, 1 times x is x, and plus x squared. So this is the factoring you will get for 1 minus x cubed. Okay? So that means go back to the problem, and I'm going to write down 1 minus x cubed as 1 minus x times 1 plus x squared. Okay, the denominator I have negative x cubed into 1 minus x. Now simple, these two gone, cancelled. Now plug in 1 and check. Yes, you will get 5, and this is 1, and that is also 1 over minus 1 cube. Yes, you are getting good number now, which is negative 5. Okay, so using the second alternate form of the derivative definition, we could find, the derivative of the function, right? So you have more work, no? So
Let me ask you, with that -5, when you add the 3, would you multiply the 3 and get 15, -15?
oh yeah, you're correct. You are multiplying these two, right?
Yes.
Yeah, sorry for that.
So it'd be -15.
So that is the derivative of the given function 5 over x cubed at 1. You could check your answer whether correct. How? You know now
Yeah.
finding the derivative without this definition as well, right?
Yes.
So you could use just now, the power rule and all you studied in chapter 2. So you could find the derivative without the alternate form, right? So you could check whether you got this answer correctly. Remember, the given function was now 5 over x cubed. Okay. Okay, use the power rule and find the derivative. Remember, this could be written as 5 times x to the -3, right? If you move the denominator to the numerator, you have to put the negative sign. Now, if you use the power rule, remember the power rule for the derivative? You have this rule, right? Now n is -3 in my case, our case, sorry. So this is going to be 5. If you're plugging n is -3 into your formula, you will get -3 x, -3 minus 1, right? So that is -15 x to the -4. That is -15 over x to the +4. That is f prime at any point x. But the question was finding f prime at 1. Simply plugging 1 here, you will get -15. Very simple, this method, right? But here you had more work because this is the basic tool to find the derivative, isn't it?